Hello students, welcome to Vipin Sharma Physics channel. Dear students, some of my students they have doubts in the waves chapter of 10 plus 1. They have asked me, randomly about the standing waves in string and all. So since I haven't covered in the YouTube waves as such with the high definition, so I've decided to upload the whole chapter in sequence. So here we start with the wave chapter. Well, students, first of all, I would like to tell you what is wave motion. And in this chapter, you must be having a very good knowledge of the topic of oscillations. Oscillation is very important to be clear. So assuming that you have got a good knowledge of oscillation, let me start with the wave motion. I will try to upload this completely in shortest time. I know exams are approaching fast. In order to understand the concept of the wave motion, its important characteristics, we consider here a well-known example of stone dropped in still water pond. When a stone strikes the calm water, when a stone strikes the calm water surface at some place, a disturbance is created at that place. When a stone is thrown into a calm water, some disturbance is created at that place. The disturbance or water ripples spread out in all directions. The disturbance or the water ripples spread out in all directions. From the point where the stone falls. From the point where the stone falls. The water ripples move away in the form of crest and trough. Like we have thrown a stone. This is a board, which is a calm water. When we throw a stone, then water ripples travels in all directions like this in the form of crest and trough. A sine wave is y equal to r sine omega t. A sine wave is created. If small piece of paper are now thrown on the surface of water, it is found that they do not travel with the wave from place where the stone strikes, but only executes up and down motion. It shows that whereas the waves are formed due to the repeated periodic motion of the wave molecules, but the water molecules do not move themselves along the wave. You might have seen a boat, a boat placed somewhere in a still pond of water, big pond of water. Ripples are formed and the boat is moving up, down, up, down, up, down, but it's not moving away. So disturbance is traveling, up and down, but it's not moving away. So that is a wave. The mechanism of wave propagation on the water surface. I'm going to tell you, first of all, I've told you what is wave motion. Now I'm telling you mechanism of wave propagation. Well, the mechanism of wave propagation on the water surface can be explained on the basis of two properties of the medium. One property is elasticity, and other property is inertia. When the stone strikes the water surface at some place, it creates a cavity at that place. Khadda, kind of. Not that permanent khadda, pani mein, when you throw some stone, temporarily it goes like this, Due to the property of elasticity, the water opposes the change in the level. And it starts filling the cavity from all directions. Like this is a water surface, plane. You throw a stone. When you throw a stone, it becomes like this. A cavity is created. Here you throw a stone, the stone is sinking down, cavity is created. When you throw a stone in water, temporarily आवाज आता है. So cavity is created. So when cavity is created, what happens? Water has got an elastic nature. So, dear students, the phenomenon of elasticity takes place, and you find that the phenomenon of elasticity takes place. You find that to oppose the change, it restores its configuration due to the elastic nature. And water opposes the change in its level and starts filling the cavity from all directions. Because the water coming from all directions is in motion, due to the property of inertia of motion, it continues to come into the cavity even after it is completely filled. What is that? Inertia. What is that? Inertia. That is called what? Inertia. So that inertia, that is how the inertia is. Like you throw a stone, a cavity is created. When a cavity is created, then water starts filling the cavity. Motion is created. As the motion is created, the motion continues due to inertia. As a result of this, the level of water at that place becomes higher than the surrounding level. So, water continues to pour. It becomes like this. So, this is called crest. Then becomes trough. So, ripples are formed. Interesting. So, water again opposes it due to the property of elasticity and falls down. So again, what happens? A cavity is created. Very interesting. Physics is physics, So water again opposes it due to property of elasticity and falls down. Thus the water particles at that place move up and down. These particles transfer. Yes, they are what? Motion in the surrounding, to the surrounding molecules, and come back to the original position. The neighboring particles in turn transfer their motion to their next molecules, and the process goes on. So the propagation takes place. This example demonstrates the that water particles do not leave their positions permanently. They simply execute periodic motion about their mean positions while the disturbance produced by the stone moves outward continuously. In other words, the energy initially given by the stone to the water molecules is continuously transmitted through water. Interesting. I will not repeat because you can rewind and listen. So wave motion is kind of a disturbance which travels through the medium. Due to the repeated periodic motion of the particles of the medium about their mean positions, the motion being transferred continuously from particle to particle. Second point, mechanical waves transmit energy and momentum through the limited motion of the particles of the material medium when the medium remains unshifted. In other words, the mechanical waves transmit energy and momentum, not the matter. Interesting. The mechanical waves transfer what? Energy and momentum, but not the matter. Third point, the transmission of energy and momentum is possible due to the two properties of the medium, the elasticity and the inertia. Fourth point, mechanical waves, examples, water waves, sound waves, and waves in spring also. Fifth point, material medium is very much necessary for the propagation of the mechanical wave. Sixth point, there are also some such waves which do not require any material medium for their propagation. Such waves are called electromagnetic wave. Light waves are electromagnetic wave. So students, this is an introduction to the wave motion. Hope it is clear. I am uploading in the Hindi version also. Thank you. Thank you very much.